Hi, first of all. My name is Boldižar Bednarik, and I'm a electrical and software engineer. Who here has any smart home appliances at home? And who made those appliances by themselves? Oh, that's nice. Cool. What can you expect from this talk today? What I'm planning to do is to inspire those who have not made anything by themselves yet, give some directions, and share my experience with the whole IoT and the do-it-yourself smart homes thing. I will introduce the whole field quickly and then move on to my personal history with it. I will keep it short, I promise. Then I will talk about out-of-the-box solutions that you can buy today, and then move on to DIY, and we are going to take a look at some software that can be used to automate your home. And I will talk briefly about data logging and the visualization, because I love logging data. When I was a kid, this whole thing was just a dream, like to automate your home and to, have some robots and things that do stuff intelligently. And we were watching things like the Jetsons and all those movies that you can see on the picture, and read some comics in the magazines. And we were inspired, but we had no electronic parts or knowledge or money to build things ourselves. And we wanted to really, but the political situation wasn't very good. So even if you wanted to buy electronic parts, you couldn't. So we either had to wait to something to break in our home, or to use a hammer and break it ourselves to have some parts and play around with it. Move forward to the 2000s. When I was on the university, I found something called the European Installation Bus, which is, I don't know if you have heard, who have heard of the EIB standard. It's a communication protocol which is mainly used by industrial users, and it consists of a bus. It's a separate bus, like a LAN cable, which is running through the building, and you can connect different components to it, like switches, actuators, sensors, and so on. And you have a central computer which controls the whole thing. It's a fantastic idea. This is the first time when I've seen that this is going to be the future. And I always wanted something like that in my home. It's really good because you can exchange things dynamically, move switches around, and reprogram what those things do with each other. So we have a pretty good solution, right? Is it reliable? Yeah, it's really reliable. It's industry-grade stuff. How about the implementation? How well it plays with the existing infrastructure, homes, buildings? And what about the price? Well, you tell me. If you want to use this in your own home, you have to tear down the walls, install the bus yourself. And back then, it was pricey. It is still very pricey. It's reliable, good stuff, but I don't think that you want to spend like 2,000 euros only to have this in your home. So it's not the best solution. Jump 10 more years. While I was reading one of the hacker blogs, I stumbled upon a small thing called ESP8266, which is this board. This was the first iteration of it. And when I seen the price, which was $1 or $2 a piece, I knew that a revolution is coming instantly. like something that you can hook up to an Arduino or any microcontroller that can communicate through Wi-Fi. That was unbelievable before. If you wanted a module that can connect to Wi-Fi, you had to spend like $50 or something like that, which is not, for hobbyists, it's not sustainable. First, it required an Arduino to run code, but in a week or two, some really smart people wrote a firmware to it because they noticed that it has a really powerful CPU. And in 2 weeks, you could just load code your own firmware to it and run it yourself without anything. So this thing, and it was much more powerful, like 4 times faster than an Arduino, and it had like, I don't know, 5 times more memory. I don't remember the specifics, but it was much better than an Arduino back then. So we like that. And that was like the future for me. I was really excited about it, and if you have not used it, you should be too. So let's address the prairie elephant in the room. Why bother? We have readily available smart home systems today, which are not 10,000 euros a piece. Affordable. You can order them from China or buy it on Kuću and predavanje or whatever. You can use those. Why bother? Well, I have a few reasons why to build your own smart home system. You have limitless customization, first of all. You have an idea, you don't have to rely some existing component to work. You can build your own component, which I did many times because it's fun. Cost effective? Yeah, it is. It's really cost effective. But most importantly, you are independent from the companies who are manufacturing the smart home appliances. There is countless articles on the internet where companies are have spied or like employees of those companies have spied on people who are using these components or products. Then there is so this is the privacy issue. Then I had an Arlo camera, which is like a doorbell competitor. And when I bought it, it came with a capability to save motion videos and pictures to the cloud. So you bought it, you had a pretty solid security camera with a battery. It's really nice hardware. And after 6 months, they changed it to a subscription model. So they are changing things around. You build something, you buy something expensive, and after 6 months, it turns out that it will be even more expensive with time, and they add subscriptions. They take stuff away because it's connected to the internet and because they can, of course. Then there is the risk of hacking. Hackers are not attacking custom-made boards and custom-made systems because they don't have all day to attack everyone separately. They tend to find vulnerabilities in components and products which are on the shelf, which are available everywhere, which many people are using. So it's much more likely that you get hacked and have problems with your heating or with your alarm system or whatever you are planning to use if you are using off-the-shelf products. And then there's support problems. So they just drop the support after 3 years, and you spent like 1,000 euros on something that now you can't use reliably because they moved on to another product. All of these things, all of these problems you will not experience with DIY stuff because the open source community will maintain products because we are just crazy. No, because they like what they are doing. So, oh yeah, and you can learn a lot while playing around with these things. Sorry. So how does the infrastructure of a DIY, or as a matter of fact, any smart home look like? You have nodes, as I call them. These are the nodes. These are the dumbest part of the smart home. These are the cheapest and most simple parts of the smart home. These are where the data. So these are the components, the sensors and the actuators, the lamps that you are using locally in a room. Then you need some medium for them to communicate. This can be a Wi-Fi network, a LAN cable, or Zigbee, or whatever. There is a lot of different protocol that can be used. We are going to cover Wi-Fi and Zigbee. Then you have the communication, but these things are not compatible with each other. So these cannot talk to each other if you have a Zigbee device and a Wi-Fi device. That's why you need a common language, a protocol which helps devices communicate with each other. In our case, that will be MQTT. Then you need something that can control and connect everything together. You need a brain for it. That will be the server and the Node-RED application in our case. And then you need a user interface or any interface to use the whole smart home system. We will talk about all these different parts a little bit. So network, as I said, you need, in case of Wi-Fi, you need a router and a 2.4 gigahertz network, because right now there is no, that I know of, 5 gigahertz modules for Wi-Fi and smart home. But every today's router supports the legacy frequency, so that's not a problem. And for Zigbee, you also need a router. Well, kind of, sort of. Wi-Fi nodes. So we are going to talk about two types of nodes, Wi-Fi and Zigbee. The Wi-Fi nodes are ideal for do-it-yourself applications, because if you buy a ESP8266 or ESP32 chip, or any package, I prefer the VMOS D1 Mini, by the way, if anyone's interested. This is a really good small package, works very reliably, and it has a ESP32 variant, which is backward compatible. The legs are on the same, so you can drop in, use it like a drop-in replacement if you need a stronger one. But if you don't like the smell of burning solder in the morning like I do, and you don't want to get your hands dirty, then you can buy off-the-shelf parts from China or from whichever store for a fairly low price. We are talking about a few euros for a switch, which uses these CPUs as well. And you can modify them really easily, like not physically, but you can use your own firmware on these components. There is also, if you have existing, and I place them in the Wi-Fi categories, but if you have old sensors, like motion sensors, which are using the 433 Hertz radio frequency network, you know those Chinese elements, like you have remote control to turn on different sockets, you have lamps, you have motion sensors, and so on. There is a radio frequency Wi-Fi bridge that can be updated with a firmware and use it in your own system as well. And then you also will need software for all these. You can write software if you are into that stuff, and I encourage everyone to at least to try, because it's fun. It's not that hard. All you need is one of these chips, a light emitting diode, a push button and a cable to play around with it. And if you can make a simple code like push the button and light up the LED, then you can do anything, basically. I'm not exaggerating, so that's fun. But if you are not into that, there are available open source firmwares that you can compile and copy to the hardware really easily. There is simple tutorials all over the internet for these. And what I like to use is EasyESP. It's a simple firmware and it's pretty configurable. But there is ESP Home, which can use with all of these, elements. And it's made just for Home Assistant, if anyone is using Home Assistant. So this firmware is tailor-made for that. Then there is Tasmata, which first appeared for Sonos devices, but it supports a bunch of other right now. And you even can use these with your own custom-made hardware, but you will need to write configuration for it. Why not use Raspberry Pi, right? Because you can connect it to network, it can do all these things. It can connect to Wi-Fi. I have a really good argument against Raspberry Pi for nodes. Every time you use a powerful PC, just to read the temperature from a sensor, a puppy dies. I'm not kidding. Don't do it. Use ESP32 or 8266. So moving on. Zigbee nodes. You will need a router, which in our case is not a router, it's a dongle. It's a USB dongle. It's made by Texas Instruments, I think. Few bucks. And you can even buy it with the updated firmware ready to work with Zigbee to MQTT software. So if you search for this dongle and Zigbee to MQTT, then you can buy it. And you don't even have to modify the thing. You can use it instantly. And this is a good stuff because you connect this to your server and install the required software, and you can use any of these different Zigbee off-the-shelf parts. You don't even need to modify them. And these are really good sensors. I'm using a bunch from different companies, and they are all reliable and working as expected. Why use Zigbee when we have Wi-Fi? You can't use them everywhere because in some buildings there's too many Wi-Fi access points, and the whole ether is polluted with. So Wi-Fi will not work reliably everywhere. Plus, Wi-Fi devices are power hungry. Zigbee is made for low energy consumption, small data transfer, so it's ideal for IoT. It works out of the box. For DIY, not very much, because you can buy chips and use it in your electronics, but these are very hard to implement in my experience. You need SMD soldering, and you need a separate microcontroller just to work with them, so I wouldn't recommend it. And you have to, this is advanced electronics. If someone wants to try, cool, but I recommend using off-the-shelf parts for Zigbee. You will need no installation, it's affordable. One of the temperature sensors I'm using it for the third year now from a coin cell battery, so ideal. I love the Zigbee protocol. Then the server. You can use anything. Raspberry Pi if you have one lying around, but an old computer. I'm using an old laptop, for example. I love using a laptop because you have everything, and it's much faster than a Raspberry Pi and has more ports and everything. But you can run it even on your own. If you have a home server, you install a virtual machine and you run the software on the virtual machine. So that's a good solution. You can back it up. You don't need a separate hardware. Oh, and you can use the cloud. But my policy is that when I start to tinker with something, I like the server close to me so I can kick it if, you know, it needs a little encouragement. Server, what to use, which operating system? You could use Windows, right? It can run all the software I will be talking about. It might work. It is an enormous overkill for these applications, much slower. So no, don't use Windows. Use Linux. It's open source. It plays really nice with all the other software. It's meant for that. It's the same family. So it makes sense to use it. Small, you can use a core Linux. You don't even need desktop environment. And it's fun. It's fun to learn things. Let's move on to the communication protocol. It's called Message Queuing Telemetry Transport, MQTT, which was meant for IoT devices. It's just the thing for them. We could use HTTP or any other protocol for communication, but HTTP has a huge header and it's not very reliable. MQTT is a special language made just for this. And how it works is there is a software, MQTT broker. So there is a broker and there are clients. The broker is like the conductor of the communication. Every client talks to the broker and the broker sends the data to the appropriate clients. This is how it works. So for example, a client measures the temperatures and sends the data to broker and sends a topic. It's like a category where the temperature came from. And the other clients can subscribe to that topic, and whenever a data appears, every one of the other clients who are subscribed to that topic will get the data. It's really simple. It even has a quality of service built in. So if some data is critical to get to a client, you can flag it like high priority. I don't remember specifically what the flag is, but you can set it up. Or you can set up, if a client must get some data, then you can flag it, and when the client comes online, it will get the data instantly. The open source software that can deal with the MQTT communication is called Mosquito. It's an open source, works reliably. The central part, the brain of the whole smart home, DIY smart home, in my case, is Node-RED. You could use other things like Domotics, Home Assistant, and you can use these alongside Node-RED. But in my case, all the data first runs through Node-RED because it's the most flexible controller of all. These are much nicer, by the way, but I recommend using Node-RED still. Very flexible. How it works is you have these digital Lego pieces, and the data that arrives at the server will flow through these lines. And you build data flows, basically. You have nodes where data is coming into the system. There are nodes which will let the data through and modify them. And you will have nodes which will consume the data, so-called. But these can do anything, like can send a Wi-Fi message or an MQTT message or save something to a file. I would like to show the Node-RED in action a little bit. How does it? So this is how Node-RED server looks like when you install it. Basically, here are the node components that you can use, and you connect them together. So let's make this just a simple. This will just be a simple demonstration. This is a complex software. So this component can emit data. This is mainly used for testing. And there is a debug component. Whatever this component gets will be displayed in this window. And then you just connect them together. You have to deploy the application. The emitter emits the data, and the debug node gets it. is this simple. Everything is this simple with the whole thing. I made a much more complex demo, and it's here. So you can even make a user interface with it. There is a library called Dashboard. You can install custom libraries, like whatever you want. It supports a bunch of the things. Let's say email. You want to send an email, then you can install a component for that. Or you want to use MySQL to save data. There is a component for that. And when you install it, all the parts will appear among nodes. I pre-installed the dashboard, and I created a UI. Everything looks like this in Node-RED. These green components are the things that will appear on the user interface, which I will show in a second. So this is how this looks like when the user opens it. I made this demonstration will show how a thermostat might work. Obviously, this is not connected to real-world data. I'm just simulating it, but it works fairly well. So this is the temperature control node. I'm saving some global variables. You don't have to write code with this. You can use it with or solve almost everything with custom nodes. But I'm just thinking code, so it's easier for me to write it down than using nodes. So these are buttons which will simulate measurements from different Zigbee sensors. So the Zigbee sensor measures the temperature, sends it to the server, and whatever data is sent to the MQTT protocol will arrive at this point. I'm just simulating it, but imagine like it will appear there. So let's say a sensor measures 22.5 degrees. You see, we see it instantly on the dashboard. Let's say that it's now 17 degrees. It follows the temperature, so you can see instantly on your dashboard and open it on your phone or whatever. Here is relay status. This simulates whether the heating is on or off. Let's say you want, so the heating is now set to 11 degrees, and I want to turn the heating on. Because the goal temperature is lower than our real temperature, it will not be turned on. But if you set it to higher, you see the relay turned on. So this is a really basic demo, but just so you can imagine the things that you can do with it. Oh, sorry. Let's move on to logging and visualization. Node-RED can store data briefly. But it's not meant for storing large amounts of data. It's meant for controlling things. If you need data for longer periods, or if you're like me, who likes to know the temperature 2 years ago at 2 p.m. in my living room, then you need something, a database or something like that to save data. And also, it doesn't hurt if you can visualize it and see trends or whatever. And for this, I choose InfluxDB and Grafana, which are two fantastic tools, also open source, both of them. InfluxDB is a time series database. Time series database means it's designed for storing data which is happening in time. So the main metric for that data is time. It's ideal for saving temperatures, events, movement, whatever. It plays really nicely with Node-RED. It's fast, reliable, but it lacks visualization. It has a query language and it can visualize the data, but we need something simpler and something much nicer. That's where Grafana comes into play. These are things from my own home system, which I put on my dashboard in Grafana. Grafana supports InfluxDB out of the box. So you can connect them together and create really nice graphs and things. This is, for example, a display of real-time data. This is historical data. And you can go back, like set the granulation. It's really nice. It also has alerting. Like if you are into that, you can set up alerts for some anomalies in the data. Like if you have a temperature and you have a sudden jump or something like that, it can alert you with a notification. And you can connect other things into the system as well. So you don't, it can display data from different sources. So you don't have to use only InfluxDB. You can even, if you have a server, you can display the server statistics or whatever. And you have everything in one place. Really nice piece of software. So my experience. I'm playing around with this for almost 10 years. And I made a lot of custom stuff with ESPs and used Zigbees, and I connected together a bunch of different systems which now play really nicely with all the stuff I mentioned before. And my experience is that ESPs, Zigbee, open source software, Linux, Node-RED, really, really reliable, like really. Except when it's not. Then it's unreliable. So my advice for people who want to start using these, use it with caution if you want to use it for critical stuff. I'm using it for controlling the heating thermostat. And I always have a built-in fail-safe. So I have a separate thermostat which will turn off the whole system if the water temperature rises above some critical level, like 90 degrees. Also, I have backup solutions for critical stuff, also heating. If I need to do maintenance on this system, or I'm experimenting at 11 p.m. and I screw something up, but I still want to be warm at the winter, right? Then I just unplug the IoT system and plug in a classical thermostat so the heating goes on. It's not bad to have those things if you are tinkering. In the long run, if I don't do these things, it works, but I like to experiment. And last but not least, back up your data, like back up your server, back up all your measurements, because AI is coming for us, and in a few years, you can only pay with data. So whoever has that wins. A few examples, ideas, what you can do so you can see how flexible the system is. You can do like heating, cooling, and maybe connect actual weather data or weather forecast to your cooling heating system so you can warm up your home before the storm comes. For example, you can make an alarm system, connect to motion sensors. You can detect who is home because there is a node for that in Node-RED. Like you can see who is on your Wi-Fi network, and you can make sure that when you get home, you have coffee. If you that's your thing, you know. You can make access control systems and make them really flexible. You know those electronic controlled doors. It's not too hard to build in. You can use NFC readers. You can use sensors for fingerprints. You even can use face recognition. There is a node for face recognition in Node-RED. Automate curtain, RGB lights. You can connect your... I managed to connect my really old analog camera system to this. So when my alarm detects a movement, I save a picture of every camera in the home. And it's a really old Chinese one. It just supports the network streaming protocol, RTSP, I think it's called. So if you can tap into that, you can connect that old independent analog system to your modern new home. You don't have to buy a new one if you don't want to. It can send notifications. There is services like push-bullet, pushover, etc. And there is a node for that. You can create your own voice assistant. There is an open source version. You don't have to rely on Google or Alexa, but you can connect it to Google or Alexa if you want to, and you can tell them to turn on the light or whatever. OpenAI, I played around with that too. So if you have OpenAI API, you can use OpenAI to control your home if you want to give them that much power. So possibilities are endless. That was about what I wanted to say. Thanks, and please, if you want, thank you.